Okay, Assalamualaikum. I just want to show you how to solve this question. Okay, I got a question from one of your friends asking about this question on chapter 4. Okay, I think it's good for me to make a short video to show to all of you, okay, how we can solve this question. It is in the notes and also I think in the slide, not sure, in the tutorial. Okay, so let's see, referring to the system shown in figure, let's say figure 1 show here, the pressure at A, okay, pressure at A is maintained constant at 140 kilopascal. The total volume flow rate of water exiting from the pipe B, okay, is exit at pipe B, depends on which valve are open or closed. The pipe diameter in branch 1, so this branch 1, and 2, so this branch 2, 50.8 millimeter, okay, millimeter, and 101.6 millimeter respectively. Okay, so big, branch 2 is bigger than branch 1 lah. The use K, the minor losses equal to 0.9 for each elbow. So you have 2 elbow for each pipe, 1, 2, and 1, 2 lah, ada 2 elbows for each pipe. But neglect the energy losses in the T's and the friction loss in pipes. Okay, neglect everything, just the minor losses lah on the elbow. Assume diameter of jet at B is the same with diameter of pipe A. Okay, diameter at pipe B and A ni sama dah, sama besar. Both A and B are at the same level. Okay, the Z is the same. Okay, A and B. Calculate the volume flow rate Q, okay, Q for each of the following condition. First, the both valves open, and the second condition, only valve in branch 2 is open, and the third condition, only valve in branch 1 is open. Okay, we understand the question. Alright, so let's start. To solve for number 1, okay, for both valve open, we use the Bernoulli equation to solve this question, because they gave you the 140 kilopascal, the pressure at point A, kan? So we have point A, pressure at point A over rho G plus ZA plus VA squared over 2G minus the total losses equal to PB, pressure at point B, over rho G plus ZB plus VB squared over 2G. Because the ZA and ZB is the same, because it's the same level, okay, so we can cancel out the Z term. And because point B is open to atmosphere, so we know pressure at point B is equal to 0. And because A and B is the same diameter, so the speed, the velocity at A and B is the same lah, and it's the same, so we can cancel out. So it will leave to us only P A, pressure at point A, over rho G equal to HL lah. If we bring the HL to the other side, so this will be equal to HL. Okay, and PA, we know PA is 140 kilopascal, okay, times 1000 over rho G, so rho for the water is 1000 times G 9.81 equal to HL. Okay, so we will know the HL will be, so cancel out, so 140 divided by 9.81, it will be equal to 14.271 meter. Okay, so while we find HL, we will use HL to find the V, the V in both branch, because we want to find the volume flow rate, and we know volume flow rate is Q equal to A times V, kan? The area times the velocity. We have the area for both branch from the diameter. Okay, so we have the area for both branch. but we don't have the velocity in both branch lah. Okay, so that's why we want to find the velocity. And because this is pipe connected in parallel, okay, and in parallel kan, branch in branch, and then combine back here at B, so the HL in both branch will be the same kan, as in the notes. If you check the notes, we will know that because it is connected in parallel, okay, so the HL in branch 1 will equal to the HL in branch 2. The total loss in branch 1 will be the same total loss in branch 2. And we know HL, okay, because we only have the minor losses from the elbow and from the valve, and they ask us to neglect the energy losses and also in the friction losses. So we only have the minor losses lah. And we know the minor losses equation is summation of K, okay, the minor loss coefficient, times V. So let's do for the branch 1 first. Okay, branch 1, okay, the HL1, so V1 squared over 2G. Okay, so we have the HL1, the value for HL1 is 14.27, so we can find the V lah. Okay, so 14.271 equal to the summation of K. So we have two elbows, so 2 times 0.9, so they give you here 0.9 for each elbow, 0.9 plus the K for the valve. So they have you the K for valve is 5, so plus 5. Okay, so this multiply with V1 squared over 2G. Okay, we can solve this to find the V lah. Okay, 14.271 it will equal to 1.8 plus 5 times B1 squared over 2G. Okay, and this can B1 squared over 2G will equal to 14.271 divided by 6.8. Okay, and we will get 2.098. Okay, and we can find V will be equal to set of 2 times G times 2.098, and this will give us the V1 equal to 2 times G times 2.098 set of V, that will be give us 6.417 meter per second. Okay, so the velocity inside branch 1 will be equal to 6.417. Okay, and in branch 2 we do the same for branch 2. So I write it here. So branch 2 HL2 will equal to again the same summation of K times V2 squared over 2G, and this is 14.271 because it's connected in series, parallel, so the loss is the same lah in branch 1 and branch 2. So this will be again the same. They have two elbows, so 2 times 0.9 plus the K for valve. So in this branch 2 the K is 10, so plus 10, and this will times with V2 squared over 2G to find the V. And if you solve this one, you will get V2 is equal to 2 times 0.9, 1.8 plus 10, 11.8, and 14.271 divided by 11.8, and then times 2 times G, and then set of that you will get 4.871 meter per second. So now we have the velocity in both branch, 4.71. So now we can solve lah all this question. Okay, for number 1, both valve open. So number 1, both valve open will be QB equal to Q1 plus Q2 lah kan, Q1 plus Q2. Okay, so this is just A1 V1 plus A2 V2. Okay. You have the A for branch 1, you have the A2 for branch 2, and you have the V1 for branch 1, and you have the V2 for branch 2. And if you put everything here, let's sorry, let me add the slide. Okay, so the QB will be pi r squared times V1 plus pi r squared, r squared. Okay, pi r squared times V2, and this will be pi times the up for branch 1 will be 0.0254 squared times V1, so V1 is 6.417 plus pi times R2, the radius for branch 2 will be 0.0508 squared times V2 4.871. And if you calculate this, you will get the answer. The flow rate, if the both valve open, will be equal to 0.0525 meter cube per second. Okay, and the second question, they ask you if the branch 2 is open. Okay, if branch 2 is open, so the QB will equal to Q2 lah, Q in branch 2, okay, which is pi r squared times V2, and this is this one lah, will be this one, so pi times 0.0508 squared times 4.871, and this will be equal to 0.0394 meter cube per second. And question number 3, if on valve in branch 1 is open, okay, so QB will equal to Q1, and it's a pi r squared times V1, and this will be in this term lah, okay, pi times 0.0254 squared times 6.417, and should give you the answer is 0.013 meter cube per second. Okay, that's all. Thank you for asking, and hope it helps you in your revision for chapter 4.